So we now have tools for dealing with pushing negations inside logical expressions that involve any of these symbols here. So we already knew how to work with negations and or, conjunctions and disjunctions, and that was Demorgan's laws. And we just figured out also how to make negation interact with these two. That was the two rules, quantifiers and negation, which are also sometimes called Demorgan's laws. And negation and implication, that's over here. That was derived rule 19 here, negating and implication. So it's not the case that phi implies psi, if and only if both phi and not psi. So with all of this, we have sort of a complete toolkit for negating lots of logical expressions. So let me give you an example. Okay, say you've got a statement like this: for all A, if phi, then there exists a B such that psi and omega. And you would expect, I guess, that phi involves A and that psi and omega probably involve B. So what if you wanted to say it's not the case that this is true? Then there is a way to push the negation symbol inside all of this and get an equivalent proposition, equivalent to this one, but with negations only appearing in the innermost positions. So the first rule you would use is, well, you're negating a for all. So according to quantifiers and negation, the one we proved in the last video, the for all becomes there exists, and you can push the negation inside. Then you're negating an implication. So to negate an implication, when is phi implies something false? Only when phi is true and the something is false. That was derived rule 19. And negating this there exists, I can push it through and it becomes a for all. That was the other quantifiers of negation. Let me just do that by erasing. So now it becomes for all B, and the negation goes inside like that. And then negating this and, just use the original Demorgan's laws. It pushes through and this and becomes an or. So not psi or not omega. Just like that. Now there is another step we can take. So I would say that at this stage the negation has been pushed all the way through. So from what we started with is equivalent to this, and the negation has been pushed all the way through in the sense that negations only appear on these proposition placeholders that can no longer be broken down without knowing more about what they say. So this is good. But one thing that you can do that would make it even better to cut down on the number of negation symbols and just simplify the statement is this. So I'm just rewriting the same thing for now. But here, instead of saying not psi or not omega, you could say psi implies not omega. So here, I'm using derived rule 18 to do this, implication in terms of disjunction. So you see, if you have an or where one of the two things has a negation on it, then you can rewrite it as an implication, like this. So here we have an or where both things actually have negations on them, so you could write psi implies not omega, or you could have written omega implies not psi. And now we've got the original thing rewritten, but with just one negation symbol, and it's on one of the innermost propositions here. So this is pretty nice. And I should add, it's also very useful in practice. This is something you will probably do a lot, especially if you take more math classes later on. Because, a lot of things a lot of properties that things could have are defined using lots and lots of quantifiers. And if you want to figure out what it means for something to not have such a property, you'd have to negate that whole quantifier's definition. And to figure out what you get after all that negating, or to simplify it into something that just uses basic quantifiers, instead of this like not for all kind of thing, you need to use the techniques showing up here. So I also want to show you how this will help you negate propositions that have quantifiers but that might not be written symbolically. And in fact, that's more normally what you will encounter, especially in later math classes. You would encounter lots of quantifiers, but with things written kind of in English rather than just purely symbolically. And it's still just as involved to negate them. It's just that the symbols are not visible, so there's an extra step of abstraction there. So here's an example, and this one is one of the ones on your quiz. Actually, what's on your quiz is just to rewrite this using symbols. So what I'm showing you now should help you a little bit on the quiz. So every person has a friend who is either very skinny or very fat. So there are a few things I ask you to do with sentences like this. One is that I ask you to figure out how to express this symbolically, and that's the content of the quiz. But also on your homework, you're asked to then negate that. So I'm going to do everything here. And when you're doing the quiz, the order in which I recommend you do this is start with the thing written in English, and then figure out how would you write that symbolically? How would you express that symbolically? And then when you're doing your homework, then go negate what you've written symbolically. So let's just work this example out. So I start with what I have written in English, and let me write it symbolically. So I'm going to work kind of from the outside. Every person has a certain property, right? Every person, for every person, that person satisfies a certain property. So for all, and I can name the variable anything I want. I could use x, but I'm going to use p for person. So for all p, so it's not that for all p has a certain property. That's not exactly what it sounds like. It sounds like it's saying every person. So I want to quantify over not just, not everything, but just the people. So for all p, how do I say, for only people, how do I say all people have this property? So for example, if having a friend who's either very skinny or very fat were like being green, then how do I say all people are green? So think back to that example, all flowers are green. How do we quantify over fewer things? We use implication. So for all p, if p is a person, then p has this property. So we can do this kind of in stages. For now, I can just write out the property. P has a friend who is either very skinny or very fat. Because that parenthesis should be green. And now, this portion, P has a friend who is either very skinny or very fat. I can work on that on its own. So now how do I write this? So has a friend who has a certain property. Has is kind of a way of expressing in English an existential quantifier. P has means there exists, right? There exists something which is both a friend of P and who is either very skinny or very fat. So this is like there exists. This has. So I would say for this, there exists, and then let me come up with a good variable name. So I could use X or Y, but what I'm saying exists here is a friend, so maybe I'll use F. There exists an F such that F is both a friend of P and F is either very skinny or very fat. So maybe I could write that in English to start with. F is either very skinny or very fat. But then I might notice the or and then just replace that. Make a replacement there. Or F is very fat. So then, writing out the entire thing, it looks like this. Just like this. So, just reading this again, for all P, if P is a person, then there exists F, such that F is a friend of P and F is either very skinny or very fat. So for all people, they have a friend who is either very skinny or very fat. So that's all you need for the quiz, but when you're doing the homework, then you'll also be asked to negate these. So, for example, how would you negate this original statement? So what I would suggest is write it symbolically, like we've done here, first. Then negate what you've written. So let me stick a big knot in front of everything here. Let me make that red. How about I zoom out here? So there's a negation, and then use the rules. So this is the same as, and then the negation can be stuck inside here. So this becomes there exists P, using our quantifiers and negation rule, such that it's not the case that if P is a person, then there exists F, such that, and then all that stuff in yellow in there. And negation with the implication, to say it's not the case that if P is a person, then blah blah blah, is to say that it is the case that P is a person and not blah blah blah. So this becomes there exists P such that P is a person and it's not the case that there exists F such that all that stuff. And then to negate, there exists F such that all this junk here I would say it becomes for all, using quantifiers and negation rule, for all F, and then the negation of all the stuff in here. So it's not the case that F is a friend of P. And let's allow this to take up multiple lines here. It's not the case that F is a friend of P and F is very skinny, or F is very fat. So the negation is on all of this portion here. And then I need to close that parenthesis, and I need to close that parenthesis. Okay. Lots of parentheses. So now this negation can distribute over this and using Demorgan's law. So there exists a person such that for all f, now f is not a friend of p, or it's not the case that f is very skinny or f is very fat. Let me just write Vs for very skinny, or f is Vf for very fat. Okay, and then this not can distribute also. So this will again be Demorgan's law, not distributing over an or. So this is overall an or. Okay, so I've rewritten everything here, and now I'm writing this with Demorgan's law applied to it. I would say f is not very skinny, and f is not very fat. F is not, let's say Vs for very skinny, and f is not Vf, very fat. All right, and now you could say the negation has been pushed in as much as possible. So we only see negation showing up here, here, and here. So I would say that it's pushed into the innermost propositions. I don't see any other way to break these down symbolically. They're just kind of basic predicates. All right, but it's a little bit unnatural to have a, so we can still do better. I would say it's a little bit unnatural to have for all f, either this or that is true about f. That's not as natural as if we were to write it using implication. So remember from the previous lecture, from Friday, we saw that for all works really well with implication in terms of just having the effect of quantifying over fewer things. Just like there exists works really well with and for quantifying over fewer things. So if we can pair up for all with implication, and even better, if we can cut down on the overall number of negations showing up while doing so, then that is good. So here I see it's not the case that f is a friend of p, or, and then this other junk. So now I'm going to go back to that derived rule 18, which says if it's not the case that something is true, or something else is true, then you can rewrite that as an implication, like this. So going back here, I can basically erase this not, f is a friend of p, and then turn this into an implication. And that would also be equivalent. So now let's rewrite this in English. So to rewrite these in English, what I would recommend is starting from the inside and then working your way out. That was kind of the opposite of this process of taking something that was originally written in English and trying to write it symbolically, right? For this process, we worked from the outside. I sort of made this portion symbolic, and then I had a non-symbolic thing inside, and then I worked on the inside. So I worked from the outside, and then I went in. But here, I'm going to do the opposite. To go and write this in English again. So working from the inside, So I'm going to keep this stuff the same. There exists P such that P is a person. And then let me express this for all F portion in English. So for all F, if F is a friend of P, then F has this property. In other words, all friends of P have this property. So all friends of P have this property, which is that they are both not very skinny and not very fat. So maybe I can say it like this, are neither very skinny nor very fat. Meaning they are both not very skinny and not very fat. Okay, so that was one step, working on the inside of trying to get it to be written in English rather than symbolically. Then, now this overall is saying there exists a person who has this property, that all of their friends are neither very skinny nor very fat. You notice how when I write it in English, I managed to get it so that I'm not mentioning the quantified variables. So this is still a little bit awkward. We can still improve this. But I just want you to see that there are no quantified variables showing up here. Back here, with the P showing up, that was fine because I was just trying to write this portion in English. And this portion that I'm underlining in blue does not have P being quantified. That portion is inside the scope of this there exists here. So definitely I would have to mention P no matter how I express this portion by itself. But overall, the P is quantified. Okay, and then this is still a little bit awkward. There exists a person with the property that all of their friends are neither very skinny nor very fat. People don't talk like that. Maybe we could say there exists a person whose friends are all neither very skinny nor very fat. Like that. And I hope also that you can intuitively feel that this is a negation of what we started with. So if someone goes up to you and says, hey, every person has a friend who is either very skinny or very fat, then what would be the exact opposite of what they're saying? What would be the negation? Or what would make them out to be a liar? What would you have to establish to make them out to be a liar? You'd have to establish that there is in fact a person whose friends are all neither very skinny nor very fat.